Dear students, welcome all of you for my Chem Club YouTube channel. Today you will learn how to balance oxidation and reduction reaction. That means how to balance a redox reaction. Actually this video is for English medium students. You will learn how to balance a redox reaction step by step from this video. If you do not subscribe my YouTube channel, please subscribe our YouTube channel and also click the notification bell. Now let's join with our video tutorial. In redox reactions, they have contained two kinds of reactions. What are they? Oxidation reactions and reduction reactions. Right. They have two kinds of reactions, oxidation reaction and reduction reactions. Now let us see what are these oxidation reactions and what are these reduction reactions. In oxidation reactions, the oxidation number of a component will be increased during the reaction. In reduction reactions, the oxidation number will be decreased during the reactions. But those oxidation reactions and reduction reactions cannot be occurred individually in a medium. Both of these reactions will occur simultaneously inside the medium. As an example, there is a reaction. Imagine this reaction will be occur inside an acidic medium. Right. Now this is permanganate ion. This is ferrous ion. Permanganate ion is reduced to Mn2 plus ion. Fe2 plus, otherwise ferrous ion, will be oxidized to ferric ion. You need to write down the state of this component as well. Okay. Now let's find out how you'll balance the following equation. First of all, you need to calculate the oxidation number of these ions and compounds. First, MnO4 minus. Imagine you don't know the oxidation number of manganese. Because of that, you have to add X for oxidation number. Plus, what is the oxidation number of oxygen in here? Right. The oxidation number of oxygen is -2. They have 4 oxygens. Because of that, you have to multiply -2 by 4. It's equals to the charge of this ion. What is the charge of this whole ion? The charge of this whole ion is -1. It's equals to -1. Now X minus 8 is equals to -1. X equals to +7. Right. Now you can figure out the oxidation number of manganese, manganate ion, is +7. Now you can write down in here +7. Right. What's the oxidation number of Mn2 plus? The oxidation number of Mn2 plus is +2. Now the oxidation number of manganese was reduced from +7 to +2. What is the difference between the oxidation numbers of those two ions? Yes, the difference is 5 electrons. Right. Now the oxidation number of Fe2 plus is +2. Now you can see the oxidation number was increased +2 to +3. Now the oxidation number of Fe3 plus is +3. What is different? The different is 1 electron. Now they have 5 electron difference between MnO4 minus and Mn2 plus. You have to exchange those different to Fe2 plus and Fe3 plus. Now you have to add 5 here. They have 1 electron difference between Fe2 plus and Fe3 plus. Now you have to exchange the difference to MnO4 minus and Mn2 plus. 1 here and 1 here. Next step, you have to balance oxygen atoms. Now they have 4 oxygen atoms in here, but they have no oxygen atoms in my right hand side, right? Because of that, you have to add 4 H2O molecules to balance oxygen in this equation. Final step is balance H plus ions. Now in my right hand side, they have 8 H atoms. Now they have 2 H atoms in H2O molecule. You have to multiply it by 4. 4 to 2 is 8. Now they have no H atoms in my left hand side. Because of that, you have to add H plus ions to balance hydrogen atoms in this equation. How many H plus atoms you have to add to balance hydrogen in this equation? You have to add 8 H plus to balance the hydrogen in this equation. Finally, you have to check whether the charges of left hand side and right hand side also balance. In my right hand side, the final charge is plus 70. In my left hand side, the final charge is also plus 70. Because of that, the equation will be balanced correctly. You'll balance this equation from acidic medium. Because of that, you have to add H plus ion to balance hydrogen atoms. This is example number 2. In here you can see dichromate ion. Dichromate ion was reduced to Cr3+. And in here you can see oxalate ion. Oxalate ion oxidized to carbon dioxide molecule. Okay, now let's figure out how we will balance this redox reaction. Okay, they have 2 chromium atoms. Because of that, first of all, you have to add 2 and balance chromium in your left hand side and right hand side of the equation. Okay, they have 2 carbon atoms in here. Because of that, you have to add 2 and you have to balance carbon atoms in your left hand side and your right hand side. Imagine this reaction will occur in acidic medium also. Let's figure out how you will balance this equation correctly. Now you have to figure out the oxidation number of these molecules and ions. Cr2O7 2 minus. Okay, right. They have 2 chromium atoms. Now you have balanced the chromium in your left hand side and your right hand side of the equation. When figure out the oxidation number of chromium, you have to care both of these chromium atoms together. That means you have to add X to both of these chromium plus. Now the oxidation number of oxygen atom in here is -2 multiplied by 7 is equals -2. Now X equals to 12. The oxidation number of both of these chromium atoms is +12. It will reduce to Cr3+. The oxidation number of one chromium ion is +3. They have 2 chromium ions. The total charge of both of these chromium ions are +6. Now, okay, that means Cr2O7 2- will be reduced to Cr3+. Plus 12 will be reduced +6. The difference is 6 electrons. They have C2O4 2-. Now you have to figure out oxidation number of this carbon. C2O4 2-. Right. Okay. You have to add X in here plus the oxidation number of oxygen in here is -2. -2 multiplied by 4 is equals -2. X is equals to +6. Oxidation number is +6. Okay. In carbon dioxide molecule, you can calculate. It has +4 oxidation number to this carbon. Right. It has +4 oxidation number. They have 2 CO2 molecules in here. Because of that, you have to multiply +4 by 2. That means it has +8. Okay. +6 was increased to +8. The difference is 2 electrons. Now you can simplify both of these numbers. Now you have to exchange this number to here. Now you have to add 3 also here, right? Now you have to multiply 2 by 3. Because of that, in here you have to add 6. Alright. You have to balance oxygen atoms. They have 19 oxygen atoms in your left hand side, 12 oxygen atoms in your right hand side. You have to add 7 H2O molecules to balance oxygen atoms. The final step is balance hydrogen atoms. They have 14 hydrogen atoms in your right hand side. Because of that, you have to add 14 H plus to your left hand side. Total charge of your left hand side +6, and also the total charge of your right hand side also +6. Now you can figure out we balance the equation correctly. We have learned how to balance an equation in acidic medium. Now we will learn how to balance the equation in basic medium. Okay. Now imagine aluminium will be oxidized to Al3+ and NO3- will be reduced to NH3 on basic medium. Okay. In here we can find out the oxidation number of aluminium is 0 because the oxidation number of a natural element is 0. Okay. In here the oxidation number is +3. What's the difference? The difference between those two is 3 electrons. The oxidation number of nitrogen in here is +5. It will reduce to -3. And also the oxidation number difference between NO3- and NH3 is 8. Okay, right. Now we cannot simplify 8 and 3. Because of that, you have to exchange both of these numbers. Alright, you have to add 3 here, and you have to add 8 here. In basic medium, you have to add OH minus to balance charges. In here, you have to add 27 OH minus to balance minus charge. And finally, you have to add H2O molecules to balance hydrogen ions. 36 hydrogen atoms in the right hand side. Because of that, you have to add 18 H2O to balance hydrogen atoms. Okay, now you have balanced an equation on basic medium correctly. Okay students, we'll stop here. We'll meet again as soon as possible. Until then, goodbye, take care.